When we discuss Internet of Things, it's probably a good idea as we're discussing the future to maybe take a minute and talk a little bit about the past. When I think about where we've come with technology, I kind of think about a little bit of the major milestones. Who here was involved with technology back in the 1980s? We got a lot of young folks here, don't we? When you think about it, when personal computers started spreading around, we started to move from this physical environment. If you can imagine an era with paper and with pencils and pens and very physical, very analog processes, we started to digitize our processes, right? We started to move them into computers. When we think about with the proliferation of the internet, we took all of these separate computers and we started to connect them together and we made them online. When we think about this age of mobility with smart devices, we were taking all those digital capabilities and we made them very personal, right? We started to put them into the palm of our hands. We are now in an era in which we have sensors. We've got all these different sensors that are around in which we not just have this physical world with computers moving around them, but we're really laying a digital fabric on top of a physical world. That is the Internet of Things. At the City of Los Angeles, we leverage these sensors for traffic management, for policing. We leverage it for ways to engage our citizens. We leverage it for smart utilities. We leverage it for all of these different topics. When you look at private sector, you're leveraging it in 1,000 different ways. And really, in a lot of ways, the technology tracks that you were listening, we're discussing all throughout today how things like the Internet of Things are impacting the way we're computing and the way that we're even interacting as a society. These things change our institutions, they change our values, and in many ways, they're changing and forming the new economy and the digital economy that we're discussing. This is the biggest topic of the day, because this touches most of the things. This is the Internet of Things, or as some people call it, the Internet of Everything. Fortunately for a big topic, we have a very big, distinguished panel who can discuss this. So right here on my left here is Ajay Mungara. He is Senior Product Manager at Intel. He's going to be bringing in some of the perspective regarding what IoT is and how organizations leverage it. You've just been hearing Biren Gandhi in this last one, who's a distinguished strategist at Cisco. He's going to be discussing IoT, digital disruption, and start to touch on fact versus fluff. Because there's nothing worse than a buzzword, am I right? Okay, I've got an afternoon crowd here. We're going to whip you up a little bit of the energy here. Next to him, we've got Doane, who is Deputy Executive Director at the Port of Los Angeles. He's going to be the business case. He's the individual who helps run the Port of LA, which does around $1 billion worth of goods coming through it every single day. And then next to him is Albert Liu, who is founder and CEO at Kneron. This is an IoT and digital revolution conversation. He's going to help specifically point and help us understand the relationship between IoT, cloud, and artificial intelligence. So we are going to have a panel discussion, but we're starting off with presentations. I've asked each of these distinguished speakers to give us around 6, 7, 8 minutes to start to describe their perspective on IoT in these areas. So without further ado, I'm going to hand this off to Ajay from Intel.
All right, thank you. So where is the clicker? Clicker? Over here. Oh, right there. Yeah, IoT is going to definitely transform all of our lives. It's going to transform the way we live. It's going to transform the way we conduct business. And the reason why this is going to happen is every technology evolution has an inflection point, and we have reached that point today. And the reason for that is we think that the number of devices that are out there and connected, that's going to be like 50 billion devices, and I think that comes from Cisco, and now they said it's even more than that lately. So, and then we have like 200 plus billion sensors out there. And if you can imagine, 85% of all of those devices are not connected. Today, every one of you have something that is connected either in your pockets, which is the phone, or you're just wearing one like a watch. That's really a good form of connected devices. But 85% of those devices that you have, like from anything that is at your home or in the factories, are not still connected. And like in Intel, everything we believe is got something to do with Moore's law, and it's simply a law of economics. And the law of economics states that the cost of these sensors are really going down in the last 10 years. So it really enables every device to be able to use these sensors, right? And the cost of bandwidth, and there was times in which we used to pay money for sending texts. Nobody pays that anymore, right? I mean, so that's a bandwidth cost. And the cost of processing the data has also gone down significantly. The I of IoT is internet, and the T is the things. So far, what we have witnessed is the internet of people. That means people were needed to generate data, and the goal was for people to do something, to click something, to advertise something, and your goal was to get people to do something, right? That's what it was. And today, it is about making those things really smart. As with any technology, as I said, it's an evolution of IoT, and we believe it goes in 3 phases. First is connect the unconnected. Second is making those connected devices smart. And finally is the software-defined autonomous world. We will walk through these phases. And in a connect the unconnected world, it is a basic definition of IoT. Take a thing, simple set of sensors, find a network infrastructure, and take that data and process it in the cloud, right? So the goal was to figure out the best and the most efficient way to take that sensor data and use that data to kind of store, analyze, visualize, and make some intelligent decisions. That is IoT, what we know of today. But that is changing, right? I mean, like, fine, we connect, like take a smart vending machine, for example. You connect that smart vending machine to the cloud, you're able to make more intelligent decisions. The intelligent decisions could be like, hey, look, we are out of Pepsi, so send somebody to kind of fill in that Pepsi bottles, right? So that's what it is really happening today with the connect the unconnected world. But then we are going to move the compute more towards the edge, because if every piece of data that you're going to keep sending it to the cloud, then you're going to have lagged decision making. That's not going to happen, right? Like imagine that if you're in a car and you have a sensor that says, hey, look, you're in the front of the car, and you're going to take the data to the cloud and says, you're too close to the front car, so please brake. By the time you'll be dead. So you got to really push the compute more and more towards the edge, and that's what it is about making those smart and connected things. So imagine if the vending machine that we talked about is smart now, so it will be able to tell you a lot more information. Hey, look, I need service. I'm running out of thing, or I could more power efficiently run my machine. So I will not turn on if I don't see people around me. So there is things that you could do that can sense things and make local decisions. And that's what happens. But then things will start moving towards this software-defined autonomous world. The software-defined autonomous world is where things are going to become automated, where the machines will start talking to each other. They will start being able to make intelligent decisions. For example, the smart vending machine could have things that says, hey, look, the weather outside is too hot. There's a lot of demand, so let me do a surge pricing so I can start charging more. So it is able to make more intelligent decisions on what you do. And that is the reality. That's where the future is. That's where we are headed. And that's what IoT is taking us there. And of course, it is not like everything is fought with challenges. And I will leave you guys with one challenge. I was part of an effort that did this smart city project initiatives in Rome and in Italy and London and all of that, right? So we had like 5 or 6 different companies got together and we created this smart city solution. And one of the jobs that I had as a product manager was to figure out who actually ended up going to make money. Once we scale it to a lot of cities, who's going to make money, right? Then there was big companies like Intel, Cisco was involved, IBM was involved. There's a whole range of companies that were involved. And after I was done with my ROI calculation, guess which company in any kind of calculation made the most money was a company that supplied labor who could climb up the pole and fix those gateways. So that was a company that made the most money, right? Like all of us, we think like, it's a technology problem, the IoT, but it is still a non-technology problem. And the impact that this technology is going to have, we got to solve a lot of problems from both the technical point of view and from a business point of view. from interoperability to integration to analytics, and there is from a business perspective, we are going to have challenges with security, privacy, and all of these fragmented solutions need to come together. And I believe the inflection point is now, and with that point of view, and with giving him the clicker, I will pass it on to Biren.
Thank you. So great points, Ajay, and I'll skip over many of those points which are already touched upon in the interest of time. So it's a lot of fluff out there, right? Whenever we hear this Internet of Things, IoT, we hear a lot of big numbers like $60 billion potential for smart home market, 50 billion connected devices. In fact, like Cisco is the one who initiated that number, but many times we get overwhelmed with all these numbers and big ideas. But how much is it real, in fact? What is the fact? If you drill deeper into what is the reality, how closer these numbers are. So let's take a simple use case. Oh, this background image is not showing up, but it is about Harley Davidson. So Harley Davidson was actually going through this usual challenges of global competition, customer behavior shifts, and costly labor, and production and IT, OT and IT. They were disconnected units and had no clue about how to work together. Everything was quite siloed, and productivity and agility were like almost at the bottom. So when they adopted the IoT, and what they adopted is it's a detailed case study, but the results, these are the real business results. They were astonishing. So troubleshooting times, previously they had in days, they went down to seconds, 80% faster decision making, and the most importantly, that build to order cycle time, there was like the biggest problem they had. It was 18 months. That reduced to 2 weeks. So overall, on all the fronts, they were measuring these business outcomes, and those outcomes were remarkable. So IoT, if you adopt in the right spirit, it could drive significant business outcomes. So it's not all is fluff. And these outcomes reside on these three pillars. One is the transformation of the processes and business models, empowering the workforce efficiencies and innovation, and then the third is the experience-driven things. So just one quick thing, as Ajay was saying, like lots of devices are automated and they are brought onto the network. It's predicted that 1 million devices will come onto the network per hour in the future. So you cannot have today's manual processes and paperwork and workflows cater to that kind of volume in the future. You have to automate a lot, and you have to orchestrate those things a lot. Same thing, on the manpower efficiency and engagement, this was like really eye-opening survey. According to one survey in 142 countries, at least 1,000 employees, sample size in each country, 87% of today's employees are not engaged with what their companies are doing. It's a completely it's a height of employee dissatisfaction. And another remarkable fact is if the companies are successful in bringing down that number by 10%, then there was a 50% increase in the revenue per share, so direct business outcome in terms of empowering the workforce efficiency and engagement. And the third part is there was another Gallup poll they saying customers are changing their providers for what reasons? And 2 out of 3 today, they are changing their service providers based on the lack of customer satisfactions that they have. And in the future, 9 out of 10 people are going to change their providers based on the lack of customer satisfaction. So the customer experience, personalized, engaging experience is going to be another key pillar for this whole digital transformation. And as Ajay was also saying, monetization, productivity, and experience, that's what IoT accelerates to bring this digital transformation closer to home. And we'll skip on these specific verticals because there are enough examples out there. How can you increase the productivity? These are some of the leading verticals for IoT: manufacturing, energy, transportation, smart cities, and smart communities. And there are significant numbers, significant research has been done, and real projects. I'm sure Intel has executed, Cisco has executed many projects on a smaller scale, but there is enough evidence in extrapolating these numbers of IoT savings. And real quick, this is a book written by a Cisco VP GM, Maciek Kranz, and it nicely captures what we need to do. Once we know about the facts and fluff, how we differentiate, but how can you make IoT really work in your respective organizations? What are the recipes for success? So here is the quick idea. So these are 8-pillared recipe for success in IoT. And that is captured by two fundamental pillars: IT-OT convergence, which Ajay also touched upon, and the perfect storm of technology, economy, and culture. It's not only a technology play, it's a combination play. So I mean, the slides will be available later on, but partner ecosystem is really key, as I was touching upon in my previous talk as well. So open ecosystem approach, because the problems that need to be solved are both horizontal and vertical in nature. So no single company can do both the things successfully and at scale. So you need to partner with the right partners. And Cisco has been growing this partner community by leaps and bounds in recent past. But training and attracting talent. So training the old talent and attracting the new talent. And there are various innovative, creative ways. And some companies, Siemens, for example, is very successful in creating a university apprentice program for 4 years. So the people actually work in Siemens while they are earning their degree. So there are some creative ways of training and attracting new talent. Solving the real problems, getting the stakeholder buy-in, like really are people on board for what you're trying to solve the problem? That's another key critical aspect of it. Preparing for a journey, it's a marathon, not a sprint. So always think long term. Don't go for the short term benefits, because in the short term you might have to invest a lot, but the long term benefits might outweigh the short term investments that you might have to do. So have this long term marathon like approach. And technology and business, they are both two sides of the same coin. Sometimes you may effectively solve the technological aspect of the problem. So one company we were working with, they were developing enhanced manhole covers, for example. So they did a fantastic design, but they were disconnected from the real business workflow and processes. So there were people who were sweeping the roads. They were still polluting and kind of clogging those manhole covers with leaves and dirt and all that, because the business process was not addressed. The technology aspect of like having this connected manhole cover was addressed perfectly fine. So you have to think from both the terms, both technology as well as the business and workflow processes. Ensuring quick wins, because if you think for the unicorn outcome, it's hardly going to happen. So instead, focus on how can you secure quick wins and pave your way forward. So it's just like the car's headlight phenomenon. You cannot, if you have to go from here to San Jose, you cannot have the headlight which focuses the entire road on from here to San Jose. But as long as you can see about 50 feet in the front, it's okay. You can start your journey, and more new 50 feet is going to open up as you move along the way. And eventually you will be able to reach the destination. So same thing, focus on the total cost of operation, ownership, or ROI equations. Security is another big thing. It's obscurity by security was the de facto mantra for IoT so far. But as we have seen, like number of hacks happen in many companies through IoT and connected devices and sometimes non-IT systems. Security has to be number one priority for everybody involved, not just the IT staff. And finally, it's the culture. So more and more companies are becoming technologically dependent. Even though it's not a technology company, inadvertently, we are relying more and more on technology. So transforming the culture on bringing more technology awareness, more secure uses of technology, I think it's going to pay out in the long run. So eventually, I think it's the combination of all of these 8 elements which are going to be really successful in making IoT adaptation useful in your organizations. And with that, I'll pass on to Dawn. Thank you.
Thank you, Biren. My name's Doane Liu. I'm with the Port of Los Angeles. We're one of the 38 departments in the city of LA that Ted helps enter the 21st century. But I work in 2 of the oldest industries maybe ever, government and trade. And we're neither smart nor connected in our industry. And imagine, maybe it's different for younger folks, but people my age would appreciate that. Imagine trying to teach your parents how to use text message. What we're trying to do is teach our grandparents how to use Snapchat. I mean, it's that drastic of what we're trying to do. Ted mentioned that we're the Port of Los Angeles, we're the largest seaport in North America. We we receive and import and export about 8.8 million containers a year, making us the largest in North America. How many of you have used Amazon? Show me your hands, right? When you buy something on Amazon, you can click on your product and you can almost see exactly where that whatever you bought is, right? I mean, and you'll know exactly when it's going to arrive on your doorstep. But they'll even tell you, if it's in Nashville or it's in a warehouse in Riverside or it's at the UPS station in Gardena. I mean, they'll tell you exactly where that is. We don't imagine buying containers and your Target, and you're buying 1 million bicycles or barbecues or Barbie dolls, right? And you need to get those at your 1,000 stores in the United States. You have no idea where those items are and when they're going to get here. That's as simple as what we're trying to do. And so we've decided to work with GE Transportation. Let me step back a little bit. And it makes it even harder because we're not the customer necessarily of this data. But we are the government, so we're trying to use our government position, not so much as the landlord, where we own the land that we lease to terminal operators who receive shipping lines, who then work with truckers and train rail companies to get the products to the beneficial cargo owners and to their store shelves, right? So that's a complicated supply chain. We're just the landlord that provides the land to these terminal operators and helps receive the ships. But believe it or not, nobody in this supply chain is, I shouldn't say nobody, but very few of the people in the supply chain are communicating with each other and making that data available to each other so that, like on Amazon, you'd be able to know exactly where your goods are and when they're going to come. So not so much as the landlord, but now as a government, right? So now we're the city of Los Angeles, and we've got a big stake in this supply chain. We've decided that we're going to have to step up and be responsible for the connection. And hopefully, we're going to have something that is scalable, that GE can actually monetize, and sell the data to all of the links in the supply chain, if you will. So what we're trying to do is improve supply chain performance. The most important thing, not only knowing when those goods are going to arrive, is the reason you need to know when those goods are going to arrive is so that we can make the supply chain more efficient, so that we don't have interruptions, so we don't have stock out, so we don't have congestion on our docks. So we need centralized visibility, we need advanced information with dynamic updates in order to maximize performance. It sounds so easy, and it actually is. Our ships are usually around 8,000 TEUs, the normal ships you would see at the port. That's the 8,000 containers. The workhorse is around 11,000 TEUs. On Christmas, on the day after Christmas in 2015, a year ago Christmas, we received the largest ship ever, 18,000 TEUs, a CMA CGM Benjamin Franklin. It was the first voyage from Asia to America, and because we knew it was coming, and it was 18,000 containers, more than we've ever seen before, but it was the first time the ship was coming. So we had a month, actually a little more than a month, that we could go actually fly to Asia, work with the steamship lines, understand exactly what's going onto the ship, how they're going to load it, where the destination ultimately was going to be for these containers, right? So if you know that, you can say, hey, all the containers that are going to go by rail to Chicago, why don't we put them all in the same stack on the ship and make them closest to the rail when it reaches a dock? And all the ones that are going to warehouses for redistribution, let's put them here because that's where the trucks will be able to pick them up. So just planning in advance like that with a 30-day headwind made it really simple. And we were able to unload that 18,000 container ship in 3 days during the holidays when people were on vacation, a day earlier than we normally would have been able to. In fact, faster than an 11,000 TEU ship. Just because we were able to have all of that information and share it with all of our partners ahead of time. That made us say, aha, there's a way to do this. Now, we don't have a month in advance for every ship. It was the maiden voyage of this one ship, and we were able to do it in this case. And in fact, sometimes we don't even get that information until 2 days before it arrives. So it's been in the water for 6 days, and we don't even get that information until a couple of days before it arrives. So we knew it was imperative to figure out how we can get that information as soon as possible. So we of course had to do a request for information and proper bidding, but we worked with General Electric Transportation. They've got a great relationship with the rail companies, with some of the shipping lines, and, oh yeah, they're one of the largest shippers in the world, right? They need a lot of stuff from a lot of places. So they're actually a consumer of this shipping information. So the challenges were unprecedented change, limited visibility, as you can imagine, the risk of congestion, as I mentioned, operational complexities, and the impacts to productivity. The solution capabilities that we've identified are centralized visibility. If we can get everyone to share this information, the truckers to share their information with the longshoremen, with the shipping lines to share this information with the beneficial cargo owners. That's critical, and it's just a matter of trying to get everyone to be willing to share that data. The advanced information, as I mentioned, is critical. Digitization, I mean, there are some folks that are they're still using fax machines with these bills of lading, right? So we need to get all of that stuff online and digitized. We need to make sure it's easy to use and secure. That's kind of a tricky one, right? So some of the information is proprietary. Ford doesn't want GM to know exactly what the products are and where they're going. So we have to be able to strip some of the data so that even though it's visible, they don't have access to the proprietary information. And then lastly, dynamic updates that are updated real time. These gentlemen know how to do that. And folks like General Electric are trying to help us get there. The outcomes we hope, because we're in the middle of still designing this, is increase in visibility, predictability, reliability, velocity, which is the time that it's spent on our docks, and then ultimately efficiency. So here's a brief explanation of the pilot that we're currently undergoing. We hope to kick it off in April. I guess we're in April now. It'll be a 6-week pilot with one string of ships. So the way that and with one shipping line, we're using Maersk. And so we're going to identify this one shipping line, this one cycle of ships, if you will. Because we're the largest port and because we're teaming up with the largest shipping line, Maersk, and because we're teaming up with General Electric, we feel that we have a real shot at making this work. We'll have a dynamic window into the cargo information. We'll have operational insights for planning. We'll have advanced information. I mentioned we only get it 2 days in advance. We're shooting for 7 days in advance. That would be about the day that it leaves the port. So when it leaves Shanghai and on its way to Los Angeles, we'll know exactly what is on that ship and where it's headed. And then the actionable, meaning the right information for the right people. Our goal is to increase supply chain performance by having visibility, predictability, reliability, and increasing throughput. It's really critical. As large as we are and as successful as we are, we're pretty inefficient. It is crowded on those docks. There's a lot of truck traffic, and we're actually running at about 40% of our actual capacity. So there's always talk about building more and increasing the size of the ports. We don't need to. If we can figure out how to be more efficient, we could double throughput by being more efficient. So lastly, this is our step-by-step plan from the bottom left. Using this connected data, increasing visibility and visualization so everyone will know where their stuff is and where it's going and when it's going to get there. We'll have analytics that we can offer everyone in the supply chain so that they can measure their own performance and build their own metrics. It will help planning, right? So that everyone will know exactly when they can get their inventory and when they can stock their shelves. And then lastly, optimization to generate optimal plans and resource utilization. Thank you, and we'll be available for questions later.
Hi, my name is Albert. I'm founder of the Kneron. Have anyone here heard Kneron before? Yeah, only one person. Yeah. So I probably will introduce you guys who is Kneron first. And today's topic I'm going to discuss with you guys is cloud plus AI plus IoT. It looks like any item here are a big topic, right? Cloud is big, AI is big, IoT is big too. And why we want to say and why we want to combine them three together here is because we really want to present an idea. That's the ecosystem that Kneron is doing. We are doing something combining cloud, AI, and IoT. We feel IoT things like humans' five sense. The microphone is just like our ear, right? And the speaker is like our mouth. And some sensor is like our skin. And like human, what is the key item of the human? It's our brain, right? And cloud is somewhere that we have the big data. We have lots of different technology in the cloud. And IoT is something we have, what we call five sense. So with the brain, which is AI, to combine them together, that we can create a big ecosystem that can enable lots of different things. And this picture, in the center is what we call the big brain in the cloud. And Kneron is an IT company, a startup that we enable the local AI, which is the missing piece that can combine cloud and IoT together. And yeah, not sure if anyone here Tencent before. Yeah, Tencent is one of the biggest Asia IT company. And yeah, Tencent is one of our biggest customer. And in last year, Tencent has a conference that they invite different of their strategy partner, including Wanke, that's the largest real estate company in China, and also Yuminhong, that's Xindongfang Yuminhong, is the largest education company in China, and also Fang Hongbo's founder of the Meidi, that's the biggest smart home company in China, and we are in the corner. So that means Tencent really treat the local AI is a big key or the important item of their future strategy plan. And here is our entire picture. We have, as what I just said, we have a technology that can enable the local AI. Then if we put the local AI in robot, then we can combine the robot with the cloud. Then with your home robot has a bigger knowledge like of the in the cloud. Then our customer in robot is Foxconn, ASUS. And in ADAS, that's a smart car. And our customer are ASUS and Tencent. And we also have like TND and GRI and also has a GeoSat in drone and other field. Have anyone here have attending the CES in Las Vegas this year? Can you raise your hand? Yeah, I believe any of you have attending CES in Las Vegas, you must have seen a product called the smart refrigerator. But do you really feel that refrigerator is smart enough? Actually, for me, it's just a refrigerator that can connect to your cell phone, that you can watch your what kind of item is missing in your refrigerator. But if we add the ecosystem we just present here, combining the AI in your refrigerator and combining the AI with the cloud, what the refrigerator will look like. It will look like when I'm walking on the street, and my cell phone, the GPS in my cell phone, recognize I'm walking on the street, and there's a supermarket in the corner, and the supermarket has a big sale in the beef, for example, and it can, and then the AI in my cell phone will connect to the cloud and check my history, and also connect to the refrigerator with a small AI in the camera inside your refrigerator. Then it can send you a list in your cell phone immediately saying that, okay, your home doesn't have the beef and also doesn't have the egg. Meanwhile, you will check your history, the medical history in your cloud and in your personal email, and saying that, oh, okay, you have anemia, then you need a red beet. So it will come out and recognize a bigger and also better list for you to purchase. Then you buy more, then we earn more, right? So in this ecosystem, something missing is the local AI capability. And that's something we are working on. So with the internet plus here, that means the plus is the local intelligence that can combine in the cloud and can search the acknowledgement from the cloud and provide you the local information near you through your cell phone AI. And in order to make it happen, we present and we also provide a technology what we call NPU. And we combine two comparators here. One is Intel, the other is NVIDIA. And our spec showing that we have a 400 times better than Intel's one and in the power consumption. And we have around 700 times better than NVIDIA's GPU. Why can that happen? Every people has a hardware design background, they will always know that it's always a trade-off between performance and power consumption. Either you sacrifice the power consumption to gain the performance, or you sacrifice the performance to gain the power consumption. But the table showing here, we are better than Intel and NVIDIA, not only in power consumption, but also in performance. How can that happen? It's because we are doing the custom design, which is a specific hardware designed for neural network. It's specific design for AI. We all know G, right? GPU. GPU is specific for graphic design. That's why it's called G. And CPU, Intel is working on CPU, and that's for specific design for computing. So that's why it's called C. And we all know AI is something that doing an algorithm to simulate human brain. Human brain contains millions or billions of the neurons that can make you to judge something. And so specific hardware design with a multi-core that can function or simulate your brain is necessary. That GPU is the most powerful GPU is only contain 128 core, and the most powerful CPU probably only contains 32 core, right? But our NPU can contain more than 1,000 core in one die. And we also show some comparator here. We show the NVIDIA's and Nirvana and Google and Qualcomm. I was in Qualcomm before. Qualcomm has the zeros, and the most right-hand side is a Kneron. And the table showing here, we have the last power consumption, which is around 100 watt compared to all of our comparison. And our performance is around middle and high. Yeah, so we are the best. Okay, and Kneron offer two kind of product. One is a software product, the other is a hardware product. And in software product, we contain 4 SDK, which is emotion recognition and smart surveillance, and also the activity recognition and smart navigation. And the hardware, we provide two solutions. One is a server-side FPGA, and the other is a local-side NPU. So we want to provide an ecosystem that can combine they can provide you the local AI in not only software side but also the hardware side, and also the cloud side AI, not only in the hardware side but also in the software side. And here's another system we call the smart surveillance system. I always tell a story to explain this system. I'm not sure if anyone have been seeing the security guy in your society or in your community. I'm from Taiwan. In Taiwan, it's very popular. It's always an old guy and sitting in your building in the first floor, and they seeing their surveillance system. They contain 32 sub-screen. How can you expect an old guy can 24 hours monitor those 32 screen all the time? It's impossible, right? And our idea for this smart surveillance system is we put a small AI in each of your surveillance camera. Meanwhile, we put a big AI in your control room. Let me show you guys an example. If there's a guy walking through your first floor, and we feel his behavior is a little bit suspicious, then our first floor's smart surveillance will check his face and upload to the cloud immediately and to check history if he is in the blacklist. Then we find he is a normal guy. He's not dangerous. But then when he walk on to the second floor, and there's another girl, and give him a box, and the box contain a bomb, and he put on the bomb in front of the elevator. Then that's a normal. No, that's a very dangerous situation, right? But when our second floor's smart surveillance, because he already checked the history about that guy, so he keep tracing his behavior. So he also checked the girl talking with her. The girl talking with her, then she is in the blacklist. So then the alarm will be happen. So we are trying to show you guys a system that's more sufficient that they can check all the abnormal behavior. So that's what we call the distributed AI. They can combine not only the cloud but also the IoT. And here are the 3 projects we have been working on with Tencent and Foxconn and ASUS. And the first one is a smart car. That's the ADAS system. We can detect the lane with up to the pixel level. Then also we have something we call the abnormal behavior detection smart surveillance system. That we can detect people, then we mark the people with the green color. And whatever the abnormal behavior happen, like fighting or holding a gun or holding a knife, then we mark them. Also, we upload the face with those abnormal, with the people with abnormal behavior. Yeah, that's all.
Excellent, thank you. We're going to open up to questions, so please think of some questions for this panel. And I'm not just saying that. It's not often that you get this caliber of people. We've got startup, we've got a port, we've got Cisco and someone who just spoke in the last one, and we've got Intel in this conversation. Ajay, one thing I saw while you were speaking that really caused me to think about it is you described the way Internet of Things, IoT, is shifting the economy. It's shifting the way revenues are being made, and it's shifting the way the economy is even producing its revenue. How does, let's say, how can someone who's attending understand where to be? So if you're running a business in the audience, where do you position yourself to be able to be a part of this shift in the economy?
Thank you for the question. And in fact, I have seen some very small startup companies come and make very big impacts. I was working with this company, a railroad company, and a startup came in by putting some sensors, by doing some data analytics and taking the data out there into the cloud, and they were able to show that you can improve with very little effort 1% of you can save on fuel, 1% of asset utilization. 1% of that asset utilization resulted in a $700 million saving per year. And 1% fuel efficiency allowed that company to save about $200 million a year. And for a startup company, when they are like just some 6 people coming in, they're able to retrofit some of these trains with these sensors, some of these assets with this thing, and take that data and do that analytics With just 1%, you can imagine the savings. And in the port that I was talking about, with 1% of knowing what exactly is there in that container and where it needs to go, we are talking about billions of dollars. And for a startup company, people are willing to pay if you're able to show that efficiency. It's all about that, right? At the end of the day, all of these businesses are doing some kind of a core business. And with your technology, you can show that impact very easily. That is what IoT enables you to do as a startup company.
Biren, one thing I was thinking about when you were presenting is, as we discuss the idea of a digital and connected world, probably one of the first things that people go to is, well, I don't want to give up driving a car because I can't trust the car, right? And that often starts to point to the idea, we've all seen 60 Minutes, et cetera, where they show some hacker wearing a heavy metal t-shirt who somehow takes control of my car, right? How do we ensure that in a digital and connected world, we maintain security and keep it secure?
So security, I think it needs to be thought through in a different light in the IoT digitally connected world. We always have to think about cyber physical security, not just the cyber security anymore, because what happens typically is, so far the IT systems were hyper connected in enterprises, in large organizations and setups. So you were having those firewalls and virus solutions, and we were spam filters, and we were pretty much in a good shape most of the time. Now with IoT adoption, as it increases more and more, every single thing which is outside physically, it's not in your data center, it's not in a sanctified environment where you have biometric access restrictions and things like that. It's like a traffic signal monitor which is sitting somewhere outside, open in the public. So people can physically also fiddle around with that object. Some other sensors which are out there installed somewhere on the runway, people can fiddle with those things as well. So security, it needs to be thought through in a holistic manner. How can we think about this IT, OT convergence and security as a combined solution in both cyber and physical world together? So I think it's a paradigm shift that would require some time to adopt, but I think that's the cornerstone of having really robust security mechanisms in a digitally connected world.
Now, Doane, we've been to enough conferences, and at a conference, everything looks perfect. Everything looks good. Everything looks so simple. You were probably one of the first people to be honest at a conference and say, it's not so simple, and our organizations aren't really where they need to be. In fact, the reality is, if it was really easy, our organizations would have already been there. What does it take to drive change in an organization? I think this question was even asked in the previous session. You know where you want to go. What does it take within an organization to help you get there? We all have organizations which are not in an ideal state.
Well, there's two ways to attack it. So you and I work for a very dynamic mayor, and so leadership's very important. We work for a young mayor who has made it one of his major goals to have open data and to digitize. And so he set the culture for all 38 departments. And when he sent that message to the port, it became easy for us to figure out how we do it. So that I think internally, we're on board, we're ready to make that change, even though we're government and we don't like change. On the industry side, it's a little more difficult. Like I said, we're just the landlord in this supply chain. So by bringing in a partner who can monetize this and hopefully make money at it, I think the business opportunity is what's going to make the private sector be a willing partner in making this happen.
And that's a fascinating point. Our mayor, Eric Garcetti, is certainly a visionary when it comes to the use of technology. You don't always find that. He has a lot of history and experience in it. And we're seeing innovation in the port, not just because you're trying to change your operations, but you're trying to facilitate change across the industry itself. You're trying to facilitate change not just within your organization, but all the other organizations that use your organization, use your assets. So, Albert, a question for you. First of all, if my refrigerator is too smart, will I have a problem with my food choices? That will be one question. The second question, the more important question, is why is it important to move computing and AI to the edge? Why is it important to be able to process this on the localized device or at the edge?
Yeah, let me answer your second question. It's more easy. Yeah. Okay. I think there are a few advantages for local AI. First is about the privacy. Let's say we are also working on GUI. That's one of the biggest smart home company in China. And we have encountered some problems. Some people doesn't want to share. Or if there's a camera in your home, when I like hugging with my wife, I don't want those pictures be released, right? But we all know that some hackers, they are so smart, they can always store something from your home. So the privacy is always the biggest advantage for local AI. If I am saying that your own judgment is inside your home only, it's not connected to the cloud, that will make you feel safe, right? The second thing is about the speed, right? I think for some application, for example, ADAS, smart car, or a drone, if every judgment, when I'm driving a car and I need to make the judgment through the cloud, let's say the internet delay make you 0.5 seconds, that will already make your car be dangerous enough, right? Seeing a guy and you transfer to the cloud and coming back, then you already hit him, right? And in some area, internet connect might not be that stable. Let's say desert, right? Or some rural area, for example. So I think those two are the biggest advantage for local AI. Then the third one is about the loading. If everything needs to be judged to the cloud, then that will cost a lot, right? If you can share some loading to the local, they can relieve the stress for the cloud. So I think ecosystem we keep saying like local AI and cloud AI should be combining together. That's what we call the distributed AI. Okay, that's the second question. The first question is if my research is smart enough. Actually, the story I just present, that was I think it's a little bit science, too advantage. I don't think it will be happen in the next 5 years. That's just an example, that's all.
I have a funny story where I worked with a startup company that when he was talking about the healthy stuff, right? We had a project where it was like an automated plant system. They're a simple household plant where we put some moisture sensor, and if you're able to, not enough water, then it will just give water. Not enough light, it will turn on the light. Simple project. So these people had a fitness twist to this. They connected that entire thing to their Fitbit API, and if you don't meet your fitness goals for the week, the plant doesn't get its water. So you can see the reflection of your health in the life of the plant. So that may be something for your refrigerator connected to your Fitbit API. You don't get to open it if you don't meet your fitness goals.
Very good. I don't know if I like this new world that you guys are describing. So we'd like to now open up for questions. So I don't know if we got microphones being run. Yes, no, maybe so. If we don't, please go ahead and state it, and I'll restate the question for the audience. Correct. And so if I'm going to try to restate the question, with IoT and with all the globalization involved in it, how will it affect the way people interact and how could it affect the job market? Who wants to take this one? There we go.
It's a long answer, and I don't think anybody can correctly answer that question, right? But I think the patterns are shifting. So really, I mean, irrespective of the claims of our president, like what is really stealing the job market is automation. So industrial automation at various levels is actually shifting the cognitive intelligence of humans into higher and higher planes. So initially we used to do all the physical hard work, But later on, especially in the automobile industry, like robots have taken care of all doing the physical hard work. So humans actually shifted into more higher levels of cognitive abilities, those sort of roles, right? Like white collar jobs instead of blue collar jobs, and designing jobs instead of actually manufacturing jobs, things like that. So that shift has already happened. Additional shift is also happening with AI and more cognitive learning. The computer systems actually trying to be hyper smart. So there, the human need has to evolve into something else, some other higher plane. Like what is the key differentiator humans can offer to the world in order to make it a better place? So that's on the productivity side. And on the human interaction side, I think that's, and I always have these interesting conversations with my kids. Like whenever they are into the Snapchat and Instagram world, I often take away the device physically and say, hey, get out of the home, meet your friends in the real world. Don't just be in the virtual world. But I think that's a transformation, it's a shift that's happening, how people interact. And they think when they are in the virtual world, they think that's their real world. So they are disconnected from the person sitting next to them, but they are connected to the person sitting thousands of miles away, actually. So it's a paradigm shift that we might have to live through, but I don't know what we can do with that.
Forbes had a recent study that said that 90% of millennials are heavily into social media, and 50% of them feel that it's a systemic cause of unhappiness. So the reality is, just because it's technology, just because it's efficient, doesn't mean it's always useful in every facet and every aspect. Any other questions? Got one in the back there. Great, a microphone.
Hi, I just wondering how the IoT will decide for, the decision always made, human collect the data and make a decision for the result. So what will happen to the IoT collect all the data for us, and what we need to for who made the decision?
So who wants to take a machine-to-machine as well as machine-to-human question here?
Yeah, it is that thing about connected versus smart, right? So at the end of the day, I would say that data and what data-based decisions are going to drive the change is going to happen, regardless, right? Today, like you think, like every bit of your search information, everything that you're doing online, every minute that you're spending in a shop, all of the data is being used to make those decisions to make you more efficient, make you buy more things, make you force decisions on you, right? With things, it's going to become a lot more different. When things starts to take information from other things, and once you're able to use that data to make those things more intelligent, more smart, more autonomous, that is the world that is the reality. That's what you're going to see happen in the next 5 to 10 years. And everything is driven by data. Data is the new oil, as we call it, right? Everything, every decision that is being made by things or humans is going to be reliant on data in some way or the other.
Another question. We could take one or two quick questions. One right back there. Mike's on those way.
When do you expect doctors be replaced by AI? In the next 20 years?
Is this an Albert question?
Okay. Any of your visionary can answer this question.
I think it really depends on the application. I think take one application that we are working with our customer, for example. Like for some simple things, we are helping our customer to finding some live video, some abnormal behavior in live video. Like in China, someone taking out their clothes in the live video show is illegal. Right now, our customer, like Tencent, they are hiding around 100 people. They are doing nothing, just watching those live video to see if any people is showing some sexual show in the live video. And we help them to embedding the AI to make the judgment. Meanwhile, there is something called Industry 4.0 in like another our customer in Fastcom. Fastcom, they hiding so many people are watching some default product. If there is any default product, they will take them out, right? And we can also replace those functions with some AI. But if you want to see, the AI really replace the people, with some, like, let's say, writing an article or writing a poetry, it might take longer. I think for simple things, it might be happen maybe in the next 2 or 3 years. But in the difficult things, it might happen not even in the next 10 years, I think.
Excellent. We'd like to take more questions, but we're running out of time. Feel free to come and talk to the panelists right afterwards. And so with that, let's give a round of applause to the panelists.
Thank you, everyone. Thank you, Mr. Ross. Before we end, we'd like to present a certificate of appreciation. Please give them another round of applause. Thank you.